This is now the part 22 of the LEED V4 Reference Guide for Homes Design and Construction Online Review. Again, all the pictures or images in this video are from Google and USGBC website. If you have comments, suggestions or complaints regarding the images, pictures or in this video, please email me at nelca_roco@yahoo.com, and I will immediately reply to you and take action on whatever the reason of your email. Thank you. Why I created this online reviewer. To help myself and others to pass the LEED AP exam in one shot. These are the LEED credit categories. On my previous video, we discussed the energy and atmosphere last prerequisite, the home size. Now we will proceed to the first TA credit, the annual energy use. Annual energy use is the first credit of energy and atmosphere. It is under performance path. Energy and Atmosphere Credit 1. Annual Energy Use. Intent. To improve the home's overall energy performance and reduce its greenhouse gas emissions. It is possible for 29 points. Requirements. Projects with major energy users not included in the HERS index, including pools, spas, heated driveways, and heated garages, or other major energy users not included in the HERS index must use Option 1. Option 1. LEED Energy Budget. Design and construct a building whose modeled annual energy usage is lower than the LEED Energy Budget. The LEED Energy Budget is based on the Energy Star for Homes, HERS Index Target Procedure for National Program Requirements, version 3, with the following modifications. The size adjustment factor is always 1. The building is a slab-on-grade ranch whose floor area is equal to the Energy Star reference home's conditioned floor area. There are no floors over unconditioned spaces. The gross exterior wall area is as shown in Table 1. There are 2 exterior half-light doors, unshaded, one on the south wall, one on the west wall. Glazing is 15% of the floor area. The ceiling is insulated, and its gross area equals the conditioned floor area. The storage water heater has an energy factor of 0.59 for gas, 0.92 for electric. The thermal distribution system is 100% in the attic, above insulation. The LEED energy budget shall be displayed in MBTU per year, and is based on source energy. Any major energy users not covered by the energy model, including heated driveways, pools, spas, and heated garages, must be added to the annual energy consumption of the rated home. Table 1. Exterior wall area of LEED reference home, by number of bedrooms. 1 bedroom equals 1,300 square feet or 120 square meter. 2 bedrooms equals 1,667 square feet or 154 square meter. 3 bedrooms equals 1,957 square feet or 181 square meter. 4 bedrooms equals 2,200 square feet or 204 square meter. 5 bedrooms equals 2,411 square feet or 223 square meter. 6 bedrooms equals 2,600 square feet or 241 square meter. 7 bedrooms equals 2,773 square feet or 257 square meter. 8 or more bedrooms is equal to 150 square feet or 14 square meter per additional bedroom. Individual units and multifamily buildings are compared to the LEED reference homes. Points are awarded according to Table 2. Table 2. Points for reducing energy usage below LEED energy budget. 1% reduction equals 1 point. 2% reduction equals 2 points. 3% reduction equals 3 points. 4% reduction equals 4 points. 5% reduction equals 5 points. 6% reduction equals 6 points. 7% reduction equals 7 points. 8% reduction equals 8 points. 9% reduction equals 9 points. 10% reduction equals 10 points. 12% reduction equals 11 points. 14% reduction equals 12 points. 16% reduction equals 13 points. 18% reduction equals 14 points. 20% reduction equals 15 points. 22% reduction equals 16 points. 24% reduction equals 17 points. 26% reduction equals 18 points. 28% reduction equals 19 points. 30% reduction equals 20 points. 32% reduction equals 21 points. 34% reduction equals 22 points. 37% reduction equals 23 points. 40% reduction equals 24 points. 50% reduction equals 25 points. 60% reduction equals 26 points. 70% reduction equals 27 points. 80% reduction equals 28 points, and 90% reduction equals 29 points. Or Option 2. HERS Index with Home Size Adjuster. Design and construct a home whose modeled annual energy usage achieves a HERS Index rating of 70 or better, or USGBC approved equivalent for projects outside the US. Points are awarded according to Table 3. Table 3. Points for achieving HERS Index ratings. 70 points HERS Index equals 5 points. 69 points HERS Index equals 6 points. 68 points HERS Index equals 7 points. 67 points HERS Index equals 8 points. 66 points HERS Index equals 9 points. 65 points HERS Index equals 10 points. 64 equals 11 points. 63 equals 12 points. 62 equals 13 points. 60 equals 14 points. 58 equals 15 points. 56 equals 16 points. 54 equals 17 points. 52 equals 18 points. 50 equals 19 points. 45 equals 20 points. 40 equals 21 points. 35 equals 22 points. 30 equals 23 points. 25 equals 24 points. 20 equals 25 points. 15 equals 26 points. 10 equals 27 points. 5 equals 28 points, and 0 equals 29 points. And earn 1 point for every 4% decrease in conditioned floor area compared with the Energy Star for Homes, version 3, reference home, table 4. Buildings that are larger than the reference home lose 1 point for every 4% increase in conditioned floor area. Projects cannot exceed the maximum number of points in the EA section. Table 4. Conditioned floor area of reference home, by number of bedrooms. 1 bedroom equals 1,000 square feet or 93 square meter. 2 bedrooms equals 1,600 square feet or 148 square meter. 3 bedrooms equals 2,200 square feet or 204 square meter. 4 bedrooms equals 2,800 square feet or 260 square meter. 5 bedrooms equals 3,400 square feet or 315 square meter. 6 bedrooms equals 4,000 square feet or 371 square meter. 7 bedrooms equals 4,600 square feet or 426 square meter, and 8 or more bedrooms equals 600 square feet or 55.6 square meter per additional bedroom. For multifamily buildings, home size includes only in-unit space. Credit only available for projects using the EA performance path. Behind the intent. Reducing energy consumption is fundamental to green building. Improved energy performance reduces both energy bills and energy-generated pollution that contributes to climate change. Home size, or in multifamily buildings, unit size, significantly affects the energy consumption of a building. Larger homes take more energy to operate, require more materials to build, and generate more construction waste. See EA prerequisite home size for additional considerations. Option 1 requires projects to reduce annual energy consumption below a USGBC defined baseline. Projects can achieve the point thresholds by reducing energy consumption through more efficient design, such as minimizing floor, wall, or window area, and energy efficient components, such as extra insulation, improved air sealing, or highly efficient mechanical systems. Option 2 is based on the HERS index. The HERS index is a common metric for rating the efficiency of a building. The lower building's HERS index, the more energy efficient it is. See further explanation, HERS index. The HERS index, however, does not adequately take into account the effect of home size. It does not reward smaller buildings or penalize larger structures. A home size adjustment is therefore part of this credit. Midrise buildings demonstrate a percentage improvement in the proposed building's performance compared with the baseline building performance of ASHRAE 90.1 2010, or a USGBC approved equivalent standard for projects outside the US. ASHRAE 90.1 is the primary baseline used by above code programs throughout the US to assess the modeled energy efficiency of buildings. However, like the HERS index, the ASHRAE standard does not account for residential unit size, so LEED makes a home size adjustment. In all buildings, preparing energy models early in the design process can help the project team identify options to improve energy performance and earn points under this credit. Step-by-step guidance. Homes. Select the appropriate option for the home. Projects are encouraged to use option 1, but projects with major energy users not included in the HERS index, such as pools, spas, heated driveways, and heated garages, must use option 1. Both option 1 and option 2 use the same energy modeling software and the same inputs. Energy modeling is a valuable design tool that can help identify the most cost-effective energy improvements. Model the home as designed and use iterative testing to discover more efficient design configurations. Option 1. LEED energy budget. Step 1. Contract with energy rater. Contract with a qualified energy rater to perform the required energy modeling using RENET approved software. Step 2. Create preliminary energy model. Prepare the energy model to determine the maximum allowed annual energy consumption, LEED energy budget, using the LEED reference building defined in the rating system requirements under option 1. The energy modeling software generates a report stating the reference home's maximum allowed energy use and actual energy use. Confirm that the report states annual source energy and not site energy use. Use annual source energy conversion factors as required. See further explanation, calculating annual source energy savings. Add the annual source energy consumption of all major energy users not included in the energy model, such as pools and heated garages, to the modeled annual energy use of the home. A separate calculation must be performed for each permanently installed major energy user. Compare the total energy use of the home with the LEED energy budget. If the projected annual energy consumption is higher than the LEED energy budget, investigate design modifications that lower energy consumption enough to meet the credit requirements. Step 3. Construct home and conduct periodic inspections. The HERS rater must conduct periodic inspections to verify that all specified building components are properly installed. Step 4. Create final energy model. The final energy model must include the confirmed envelope and duct leakage rates, insulation installation grading, equipment efficiencies, and all other energy-related specifications of the building. Use the LEED energy budget as the baseline in the energy modeling software. Step 5. Generate LEED energy budget report. Add the annual energy consumption of all major energy using non-rated features to the total energy consumption, MBTU per year, as generated by the energy model, if needed. Typically, a separate report is used for this calculation. Option 2. HERS index with home size adjustment. Step 1. Contract with energy rater. Contract with a qualified energy rater to perform the required energy modeling using RENET approved software. Step 2. Create preliminary energy model. Determine the HERS index of the building. If the projected HERS index is higher than 70, modify the design to meet the credit requirements. Step 3. Construct home and conduct periodic inspections. The HERS rater must conduct periodic inspections to verify that all specified building components are properly installed. Step 4. Create final energy model. The final energy model must include the confirmed envelope and duct leakage rates, installation grading, equipment efficiencies, and all other energy-related specifications of the building. Step 5. Adjust point total for conditioned area. Calculate the number of points earned based on the conditioned floor area relative to the Energy Star for Homes version 3 reference home. See further explanation, example calculation, homes. Option 2, HERS index with home size adjustment. Multifamily Midrise. Step 1. Review prerequisite and credit requirements. Read the requirements and reference standards for both the related prerequisite and this credit before beginning the simulation. Step 2. Develop preliminary energy model. Determine whether preliminary energy models will be prepared, as outlined in the prerequisite. A preliminary model can assist with estimating the energy implications of early design alternatives. Step 3. Model potential HVAC system types. Create an energy model of the proposed design, or expand the scope of the preliminary model, to analyze HVAC system alternatives early in the design process. CEA prerequisite minimum energy performance. Step 4. Update proposed model. Throughout the design process, add details to the proposed building model to reflect changes that may affect the energy efficiency of other systems. CEA prerequisite minimum energy performance. Step 5. Conduct quality assurance for energy model. Submit the energy model to a quality assurance organization for preliminary review. USGBC maintains a list of QA organizations. Step 6. Construct building and conduct periodic inspections. A qualified energy rater must conduct periodic inspections to verify that all specified building components are properly installed. Step 7. Update baseline and proposed energy models based on final design documents. Update the proposed and baseline energy models to reflect final construction details and specifications. See further explanation, finalizing the energy models for credit compliance, and review the table of common mistakes to avoid. CEA prerequisite minimum energy performance. The final energy model must include the confirmed envelope and duct leakage rates, installation grading, equipment efficiencies, and all other energy-related specifications of the building. Step 8. Determine energy cost savings. Compare the proposed model with the baseline model to determine the anticipated energy cost savings. CEA prerequisite minimum energy performance. Apply any savings from on-site renewable energy systems after minimum compliance has been demonstrated. Step 9. Adjust point total for conditioned area. Calculate the number of points earned based on the conditioned floor area relative to the Energy Star for Homes version 3 reference home. See further explanation, example calculation, multifamily Midrise. Step 10. Conduct final quality assurance for energy model. Submit the energy model to the QA organization for final review. HERS index. The HERS rating uses a scale, or index, in which a home built to the specifications of the HERS reference home, based on the 2006 International Energy Conservation Code, achieves a score of 100, and a net zero energy home score 0. The HERS index takes into account the size of building elements, window, floor, roof, and ceiling areas, and the characteristics of mechanical systems, lights, appliances, and insulation. The lower a home's HERS index, the more energy efficient it is compared with the HERS reference home. Each 1-point decrease in the HERS index corresponds to an estimated 1% reduction in energy consumption compared with the HERS reference home. Thus, a home with a HERS index of 75 is 25% more energy efficient than the HERS reference home. Calculating annual source energy savings. For separate, permanently installed energy users, such as pools, convert the energy consumption to source energy using national conversion factors. Follow the procedure outlined here. First, calculate the annual energy use of the LEED reference home. From the energy model file, record the annual MMBTU consumption for each fuel type. Convert the annual MMBTU for each fuel type to national source energy, MMBTU times 1.05 for natural gas, and MMBTU times 3.2 for electricity. The sum of the fuel's source MMBTU is the annual energy consumption of the LEED reference home. Next, calculate the annual energy usage of the home as designed. From the energy model file, record the annual MMBTU consumption for each fuel type. Convert the annual MMBTU for each fuel type to national source energy, MMBTU times 1.05 for natural gas, and MMBTU times 3.2 for electricity. The sum of the fuel's source MMBTU is the annual energy consumption of the designed home. Finally, calculate the percentage energy savings. Energy savings equals 1 minus reference home MMBT minus designed home MMBTU over reference home MMBTU. Example calculation: homes. Option 2, HERS index with home size adjustment. A 5,100 square foot, 9-bedroom home is seeking LEED BD. And C, homes certification. Of the total area, 350 square feet is an unconditioned open-air atrium. The project has achieved a HERS index of 15. The project team first determines the total conditioned floor area. 5,100 square feet minus 350 square feet equals 4,750 square feet. The team then calculates the baseline conditioned floor area using Table 1, above, which covers homes with up to 7 bedrooms. Each additional bedroom is considered to have 600 square feet of conditioned floor area. This house's baseline conditioned floor area is therefore 5,800 square feet. 4,600 plus 2 times 600 equals 5,800 square feet. A project can earn 1 point for every 4% decrease in conditioned floor area compared with the Energy Star for Homes version 3 reference home. Buildings larger than the reference home lose 1 point for every 4% increase in conditioned floor area. The team calculates 4% of 5,800 square feet. 0.04 times 5,800 equals 232 square feet. For this project, every 232 square foot increase costs 1 point, and every 232 square foot decrease earns 1 point. The team calculates the difference between the actual conditioned area and the baseline. The actual conditioned floor area is 4,750 square feet and the baseline is 5,800, for a difference of 1,050 square feet. To determine the points earned, the team divides this number by the 4% value calculated above, 232 square feet. 1,050 square feet over 232 square feet equals 4.52. Point values with 2 or more decimal places are always rounded down to the nearest half, for 4.5 additional points. Net points earned on this credit are the value achieved from the HERS index plus the 4 additional points for having a smaller conditioned area. From the HERS index of 15, 26 points are awarded based on Table 3, plus 4.5 points from the size adjustment, for a total of 30.5 points. Because the total exceeds the maximum allowable points for this credit, this project achieves 29 points, and the additional 1.5 points may be added in the Innovation in Design credit category for exemplary performance. Example calculation: Multifamily Midrise. A 60,000 square foot Midrise building features 5 housing unit models. Model A is a 1,200 square foot 2-bedroom unit. Model B is an 850 square foot studio, Model C is a 3,200 square foot 4-bedroom unit, Model D is a 1,125 square foot 1-bedroom unit, and Model E is a 1,550 square foot 2-bedroom unit. The building has 10 units of Model A, 5 Model Bs, 4 Model Cs, 9 Model Ds, and 11 Model S. Each unit's area is completely conditioned. Use the procedure described in the homes calculation, above, to determine the number of points to be awarded for each unit. Reference minus actual, over, reference multiplied by 0.04, equals points adjustment. Model A, 1,200 square feet 2-bedroom unit. Reference conditioned floor area, 1,600 square feet. Actual conditioned floor area, 1,200 square feet. 1,600 minus 1,200, over, 1,600 multiplied by 0.04, equals 6.25 equals greater than 6 points. Model B, 850 square feet studio. Reference conditioned floor area, 1,000 square feet. Actual conditioned floor area, 850 square feet. 1,000 minus 850, over, 1,000 multiplied by 0.04, equals 3.75 equals greater than 3.5 points. Model C, 3,200 square feet 4-bedroom unit. Reference conditioned floor area, 2,800 square feet. Actual conditioned floor area, 3,200 square feet. 2,800 minus 3,200, over, 2,800 multiplied by 0.04, equals minus 3.57 equals greater than negative 4 points. Model D, 1,125 square feet 1-bedroom unit. Reference conditioned floor area, 1,000 square feet. Actual conditioned floor area, 1,125 square feet. 1,000 minus 1,125, over, 1,000 multiplied by 0.04, equals negative 3.125 equals greater than negative 3.5 points. Model E, 1,550 square feet 2-bedroom unit. Reference conditioned floor area, 1,600 square feet. Actual conditioned floor area, 1,550 square feet. 1,600 minus 1,550, over, 1,600 multiplied by 0.04, equals 0.78 equals greater than 0.5. The total point adjustment is the sum of points from all model types. Savings per unit multiplied by number of units, over sum of all units. Total point adjustment. 10 multiplied by 6, plus, 5 multiplied by 3.5, plus, 4 multiplied by negative 4, plus, 9 multiplied by negative 3.5, plus, 11 multiplied by 0.5, over, 10 plus 5 plus 4 plus 9 plus 11, equals 35.5. 35.5 over 39 equals positive 0.91. Point values with 2 or more decimal places are always rounded down to the nearest half, so 0.91 is rounded down to 0.5. Thus the size adjustment for this project is positive half point. Finalizing the energy models for credit compliance. Update the proposed model based on the information and specifications for systems, assemblies, and equipment in the final construction documents. CEA Prerequisite Minimum Energy Performance. Further explanation, finalizing the energy models. Ensure that all changes made to the design have been captured in the model. If changes occur during construction that could affect efficiency measures, the model information will have to be updated accordingly. Value engineering exercises may affect building efficiency as well as credit achievement. Document the energy modeling input assumptions for receptacle and process loads. These loads should be modeled accurately to reflect the actual expected energy consumption of the building. CEA Prerequisite Minimum Energy Performance. Further explanation, exceptional calculation method. Verify the final energy cost savings. Evaluate the energy savings by end use for reasonableness based on the differences in the modeling inputs between the baseline and proposed models. Ensure that renewable energy savings have been properly credited. See further explanation, applying renewable energy savings. Applying renewable energy savings. Calculate the total amount of energy generated by the system and convert this value into the equivalent cost using either utility rates or virtual energy rates. CEA Credit Renewable Energy Production. Apply the equivalent cost directly to the energy model through the simulation software, or subtract it from the final energy cost savings calculation. Related credit tips. None. Changes from LEED for Homes 2008. Option 1. This is a new compliance pathway. Option 2. The HERS index threshold for earning points starts at 70, rather than 84 or 79. Contract language recommendations. None. Technical resources. None. Referenced standards. 2006 Mortgage Industry National Home Energy Rating System Standards. Energy Star Qualified Homes, Version 3, National Program Requirements. ASHRAE 90.1 2010 and ASHRAE 90.1 2010 User's Manual. ComNet Commercial Buildings Energy Modeling Guidelines. USGBC Residential Energy Modeling Guidance. Exemplary Performance. Projects earn 1 additional point under for exemplary performance for achieving any of the following: 100% or better improvement compared with the LEED energy budget. HERS index score of -10 or better. 65% or better reduction from ASHRAE 90.1 2010. Verification and submittals. Supporting verification materials, made available by the project team. Provide architectural plans and basis for calculating size of each home or unit. Verification team. Verify energy model output demonstrating energy savings from energy model. Verify building area for each building. Verify home size adjustment calculation, including ensuring that only appropriate rooms are counted as bedrooms, or perform home size adjustment calculation for each building. Glossary. Baseline building performance. The annual energy cost for a building design, used as a baseline for comparison with above standard design. Renewable energy. Energy sources that are not depleted by use. Examples include energy from the sun, wind, and small, low-impact, hydropower, plus geothermal energy and wave and tidal systems. Thank you for watching. Watch for the next video. LEED V4 Homes, Energy and Atmosphere Credit 2. Efficient Hot Water Distribution System. If you wish to get the PDF or PowerPoint copy of this presentation for free, please click the link below or email me at nelca_roco@yahoo.com.